Namaskar, welcome to the channel Anka Anandaharan, that is extracting happiness from different aspects of mathematics. Today's purpose of the video is to revise the concepts that are taught at plus 2 level or early pre-degree level. That is in first year, first semester, second semester level of any graduation course. So today we will discuss some of the aspects of calculus. We may involve English, Odia and Hindi while explaining the things. The purpose is just to revise the concepts so that we will be enabling ourselves to use them in different real life problems which will be considered in the future videos. So today all these 50 pages will be quickly revised. What do we mean by function? Function is a set of rules which assigns each element in D. Suppose it is D, it is E. Every element in D should have one element in E. That is one condition. That means there should not exist any element in D which is not having any image in E. Another is there should not be any point which is having two images. So every point of D should have image and exactly one image should be there. If that condition is satisfied by any relation, then that relation F is said to be a function. Now, this set D is said to be domain of f of x and E is said to be codomain, and f of D, that means set of all images of the points of D, is a subset of E, and this set is said to be image of D under F. What is f of D here? F of D is nothing but set of all y belongs to E such that, let me write down, y belongs to E such that f of x is equal to y for some x belonging to D, x belonging to D. So all those y's which are images of points of D, they constitute my f of D, which is said to be range of f. So it is range. When range is equal to the codomain, it is onto. And when every point has exactly one image and no two points should have same image, then it is 1, 1. Every point has exactly one image. This is the necessity of a function. But we can have two points having same image. It is many one. Another is no two points are having same image. It is 1, 1. And if this codomain set and range set of f are same or they are equal, then the function is said to be onto. Onto means every point in E should have at least one pre-image in D. That means it is, in that case, it is said to be onto. Pre-image means suppose f of x is equal to y. Y is the image of x and x is the pre-image of y. Okay. Now vertical line test. A curve in xy plane, suppose it is x-axis, y-axis, a curve in xy plane is the graph of a function. It is a function if and only if no vertical line intersects the curve more than once. For example, suppose this. It is not a function because at this point, the curve intersects this line more than once. So it is not the graph of a function. But this is observed. You draw any line. It is not intersecting the curve at 2 points. So such a structure is graph of a function. Now we know absolute function, that is, it is defined on any real number. If mod of a is equal, if a is non-negative, then mod of a is equal to a. If a is negative, then mod of a is equal to minus of a. That means in both cases, mod of a is greater than or equal to 0. Next is absolute value. Mod means here absolute value. Now what do we mean by an increasing function? Suppose I have here x1, here x2. If here we can indicate that, observe that x2 is greater than x1. Suppose whenever my x2 is greater than x1, my function's value also, it is my f of x1, and this is my f of x2. So here we can observe that my x2 is greater than x1 implies f of x2 also greater than f of x1. So if it x1, x2, if it is true for any 2 points x1 and x2 in the interval, then that function is said to be increasing. On the other hand, what will be a decreasing curve? A decreasing curve will be something like this. What happens here? Observe, this is my f of x1 and this is my f of x2. So it is decreasing. So my value of the function increases when x2 increases. x1 is greater than x2, f of x1 is less than f of x2. Here x1 is less than x2 implies f of x1 is less than f of x2, then it is increasing. But here, as my value of the domain value increases but the range value decreases, it is decreasing function. Now, always we know that sine function and cosine functions value lies between -1 to +1, and they are periodic functions of period 2 pi. Now these are some of the functions properties. Already I have made a video regarding this in detail, but today we will have a quick revision. Okay, so here what happens when my f of x is added with c, my graph original function, observe here, what happens? My original function's graph moves upward. If that c is subtracted, it will move downward. Observe here. It is what I am doing, I am adding or subtracting this c to the whole function. If the same addition or subtraction is done inside the argument, what happens here? Observe here, this c is added to the argument. Now my function moves towards left. If I am adding a positive value to the argument, it is moving towards left. And if I am adding a negative value, then it moves towards right. So it is f of x plus c, it is f of x minus c. Observe the same graph is moving upward or downward. But when I am adding f of x plus c, my graph moves this side. And f of x minus c, my same graph moves along x-axis towards right. Okay, so this is an observation. It will help us while drawing a function, graph of a function. Next, another. Here what happens? It is my f of x. I am multiplying a number greater than 1. Then the size of the graph will be a little bit larger. And this is, observe here, this is my f of x. Now I have multiplied here with a function with a value greater than 1. So the size increased. Now here I have multiplied the function with a value here less than 1. So it is reducing its size. It is compressed. Okay, so along this direction it is compressed. It is compressed like this. And here it is stretched. Okay, So in this case, when c is greater than 1, it is stretched, and when c is less than 1, it is compressed. If the function's argument is multiplied with -1, it will be giving me just a mirror image where the mirror is kept along y-axis. F of y is equal to f of x, this curve. Its mirror image is y is equal to f of minus x, where the mirror is kept along y-axis. Next is, here the whole function, observe here, this graph. Whole function I multiplied with minus 1. So what I am getting, how the graph is? Just its mirror image when the mirror is along x-axis. All these things we have multiplied, we have discussed. Now this one. It is just already all these things we have discussed actually. Very much, nothing much. Just we will discuss this cos function. It will give us some idea. Observe here, this function cos, this is my y is equal to cos x, this pink color. Now when I am multiplying 2 to the whole function 2, then along this side, the function is stretched to give this bigger curve. When I am multiplying it with half, then it is compressed. The curve is compressed to get this smaller green curve. Okay. So, similarly, argument, inside the argument, when I am multiplying, observe the period of the function. If I am multiplying with 2, this is the original function. This pink color here is the original function. Now when I am multiplying 2 to the argument which is greater than 1, my wavelength decreases. Okay, and when I am multiplying with half, my wavelength increases, the period increases. Observe here. This is whole function. Whole function is, that is y is equal to root over x. Now 2 is subtracted from this whole value. So this value, this curve just shifted to 2 units downward. But here what happens? Inside the argument, 2 is subtracted. So 2 units right side, it's shifted along x-axis. Now it is minus 2 is multiplied to the whole function. So if it is multiplied to the whole function, just its mirror image along x-axis we will get. So I am getting this. And when I am multiplying the whole function, this function, observe, this function I am multiplying with 2. That means its size will be increasing. So with this, today we will conclude. Next video we will discuss further aspects. Thank you.